Algebra 1, Lesson 30, Graphing Functions. Our new concepts today are linear equations. A linear equation is an equation whose graph is a line. You can use a table of ordered pairs to graph an equation. To determine if the graph represents a function, use the vertical line test. If the vertical line test intersects the graph at more than one point, then the graph is not a function. A linear function is a function whose graph is a line. A linear function can be written in the form of f of x equals mx plus b, or as you might have seen it, y equals mx plus b, where m and b are real numbers, and m represents our slope, and b represents the y-intercept. So a linear equation is an equation whose graph is a line, and it's a function if it passes the vertical line test. Remember, we learned about the vertical line test, in which if you draw a vertical line anywhere on the graph, if it intersects the line itself one time, it's a linear function. If it doesn't, it's not a linear function. So here in example 1, it says use a table to graph functions. You might be familiar with how to do this in terms of you're given an equation and you have a dependent and an independent variable. When it comes to the dependent variable, we're talking about y, of course, and the independent variable, the x. Whatever you plug in for the x value, then do the math on this side of the equation will give you a value that is dependent for the y. In this case, y equals x. Obviously, they're going to have the same values. If you would then go graph those as ordered pairs, your x value gives you your right and left movement from the origin on the x-axis, and your y value gets the up or down movement based on being positive or negative. So this is graphed 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Once you've got all those points graphed, you actually draw a line and connect the dots to show where that line goes, and then you can use the vertical line test to see if it is a linear function. So you can see that it's a straight line in this vertical format going up to the side here. And the vertical line that's drawn through it only intersects it at one point, so it is a linear function. Letter B says y equals x squared. So whatever value you pick for x, then you have to square that value to give your y value. For example, negative 2 squared is positive 4, negative 1 is 1, 0 squared is 0, 1 times 1 is 1, and 2 times 2, or 2 squared, is 4. With those points, you then graph your x values. If they're negative, they go to the left of the axis here, and if they're positive, they go to the right. So you've got negative 2, 1, 0, 1, and 2 for your x values and the corresponding y values. So those ordered pairs are graphed. Here again, the vertical line test shows that there's only one point of intersection. Even though it doesn't look like a straight line, doesn't mean it's not a linear function. The graph is not a line, so it's a non-linear function. According to the vertical line test, the graph is a function, but it's a non-linear function because of that shape. Example 2. Matching a graph to a table. So sometimes you might be asked to graph a line based on a table. Sometimes you might be asked to say, hey, what line that's graphed already matches the equation, and you have to look from the table to see if those points match up. So use the coordinates in each table to match each graph with one of the tables. So for example, in this equation, f of x equals 1/3 x plus 4, you're looking to see, does the table match the point on any of these graphs? So what I like to do is pick out maybe what would be the easiest identifiable point and then try and match those up. In table 1, you've got 1/3 x plus 4. If x equals 6 and 6 is times 1/3, that's going to be 2 plus 4 is 6. So which one of these graphs has a point of 6, 6? You would have to go over 6 and up 6 to find that point. Over 6, up 6, over 6, up 6, and it looks like the only one is graph 3. Now, I don't want to just stop at one point. I want to test two of those points. So I'm actually going to come back to this 0, because anytime I have a 0 for our x and our y axis, I can just look up and down the x and y point to see if that corresponds. So here it says x is 0, y is 4. If I go up to 4, there it is. So I know that table 1 is graph 3. Now, process of elimination, I only need to figure out one more of these, and then the other one would be the final one to match up. Let's take a look at table 2. F of x equals 5x minus 1. Now, all these are done again. What I'd like to do is start with one that I can easily identify. For example, x is 1 and y is 4. If I go over 1 and up 4, over 1, up 4, looks like I'm right here. So it looks like table 2 and graph 1 match up, but let's try one more option. I then go to the 0 and the negative 1. If x is 0, y is negative 1. It's kind of hard to see because the scale is 2 for every one of those blocks, but I believe that table 2 is graph 1. So table 1 is graph 3, table 2 is graph 1. That must mean that table 3 is graph 2. Just to show you how that works again, I'm going to go to x equals 4 and it's at 0. X equals 0 and it's at 2, and that matches up. Table 3 matches with graph 2. So you see that I took those ordered pair points, found them on the graph, and found which of those graphs corresponded not just one point, but with 2 points. In example 3, you're matching an equation to a graph. So similar to what you saw here with the graph to a table, you're going to match an equation to a graph. Now, one way you could solve this is to go the extra step and create the table that corresponds with this. So you pick numbers for your x values and then see where those show up. Another way is to use a graphing calculator to check your work. Well, Mr. Shane, I don't have a graphing calculator. Well, there are free ones available to you online. If you go to this website, which is called desmos.com, it's going to ask you to sign in. You click sign in with Google, and it should allow you free access to a graphing calculator. Here on the left-hand side, you can type in any equation, and it graphs that corresponding equation right here. I'll show you a couple of those features as we use them in our lesson today. So here we're trying to match the equation with the graph. Well, what would be good for us to do is to type in the equation and see what shape it makes, and then we can make that match happen. So the first one is y equals x plus 3. I'm going to type right in here, y equals x plus 3. Gives me this from left to right going vertical line, kind of like the slope of the side of a hill or a mountain. And that matches up and looks like graph 2. If I look really closely and I put my arrow on here, it actually tracks the different points. This is 0, 3, and negative 3, 0. If I look close on here, looks like those points match up. So equation A is corresponding to graph 2. Equation B, y equals the absolute value of x plus 3. Now, to get the absolute value, you can click this little keypad down here and open up the different types of functions. So you've got the different mathematical aspects that would be on your calculator. Here is the absolute value portion. Absolute value of x, and that's plus 3. We're going to look at what looks like the V, or upside down mountain in this case, that shows the absolute value. With an absolute value equation, all of your answers are going to be positive, because if they're in that absolute value, they actually give you a negative value. So if x is negative, that y value is going to be positive, because it is turning that negative into a positive. That matches up with equation or from graph 3. So equation B is graph 3. Order of elimination, or the process of elimination, says that equation C must be graph 1, but let's type that in just to make sure. Y equals the square root of x plus 3. Here again, I would go down to my function, click on square root, fill in the 3 below it, the x below it, and it graphs the function for me. Here again, if I click on the function, I can see where those different points are. At any point that I click, I can find an ordered pair. Obviously, when I click on one where there's an intersection directly between one of the lines that's represented on this graph, it shows it as a whole number. Otherwise, as you move from left to right, you can see that it shows up in also decimal points as well. That might be helpful. So matching an equation to a graph, obviously graph the equation. Two ways to graph that equation is to use that graphing calculator or to write out the table. You would have to pick the x values and then plug those in and then draw that table in a t-chart, x and y, find those points, graph those points, and then see where that line goes. Otherwise, the quick, easy way is to use that graphing calculator as your friend. Example 4 says identify the domain and range. Quick overview again. The domain is all of the x values. So what can the x values be on any type of graph? And the range is all of what the y values can be. In example A, you've got y equals the square root of x plus 1. The domain is x is greater than 0, because there's nothing that can go to the left of this value being negative. You can't have a negative value underneath your square root, because those are two numbers that are going to equal one number. You have all positive numbers, so that's why it says x is greater than 0 if it's going to be all positive value. By inspection of the graph, the range is y is greater than 1, because the graph doesn't come down below this 1, so it's 1 and greater in the vertical sense for your y-axis. See how that works? There's no values that are below 1. There's no values that are less than 0 for x, so there's your domain and range written in this inequality form. Letter B, you've got f of x equals x squared minus 2. Your x values go left and right, and there isn't really a stop on where those go, so the domain is x is greater than 0. It can be any of those positive values and or negative values. By inspection of the graph, the range is sorry, in this example, we're down here, the inspection of the graph, all the domain of the x values are real numbers. So any number, positive or negative, could be your x value. There is no limit on that because it can go as far left and right as it wants to based on the number that you input. However, the y value only goes down to this -2. There's nothing that is -3, 4, 5, 6, 7, or 8. So it's y is greater than -2. So y can equal 1, 2, 4, 8, all these numbers that are vertical in this sense. That's written as the inequality for the y values going upward, not the y values going downward, because there aren't any y values that are down here that apply to that equation. So you're writing an inequality based on where that graph goes. If there's ever a limit on that going left or right, that's where the x value has that limit, or the y value has a limit going up and down. Final example is a car wash fundraiser in which the soccer team raises money by washing cars. They charge $5 per car and spend a total of $4 on soap. The table shows the money they raise. Make a graph and use it to find the amount they raised by washing 7 cars. Write the rule in function notation and use it to check the answer. So in this case, you've got all of these points in which you could graph and plot like this and then connect the dots. Now this work is done for us, but we want to make sure that we're able to do something like this as well. To write this in function form, you would have to understand that your variable in this case is the number that they charge for each car. So it's $5 per car, which means that our equation is going to look like this. Y equals 5x. But now there's another factor that you have to consider. You have to spend $4 on soap, so you take that money that you have for your profit and you subtract $4 from that, and you get what that graph looks like. Now it looks a little bit different on this scale than it does on your textbook because of the way in which these points are plotted. If you looked closely, you can see that this is obviously spread out over a great deal and has the earnings showing more of a kind of flat line overall raise. But here's how you would take those 2 points into consideration. Write out that function, and then if it's asking you a specific question, for example, make a graph and use it to find the amount of money they raised by washing 7 cars. If you plugged in 7 for that equation, 5 times 7 is 35 minus 4 is 31. So if I went to 7 here, I would find that that intersection, if I back up a little bit, maybe that shows a better representation. If they're at $7 or 7 cars, they make, there it is, $31. Okay? So you can use that Desmos equation typer to plug that in and see the graph to show you what that would look like to help you solve those problems. What I'd like to do is take a look at some of those in our lesson practice. In letter A, it says graph y equals 2x plus 5. Use the table of values using a graphing calculator to check your table. So I'd like you to practice using the table, as in plug in 1 for x, 1 times 2 is 2, plus 5 is 7. Plug in 2 for x, 2 times 2 is 4, plus 5 is 9, and graph that out. Otherwise, the fast and easy way is to plug in that equation here. Y equals 2x plus 5. And from this, you can tell all those different points, especially if you, zoom in to see where that scale is appropriate. All right? In letter B, it says graph y equals x squared plus 1. X, if I go down to this little tab here that has the number over the top, it'll put in the squared, and then I space plus 1. It'll show me that graph that I just created. You notice that when I added plus 1, it moved the x up. Now my domain is all real numbers because the x values can be left or right, but my y values are greater than 1 in this case. Does this graph represent a function? Yes, because it passes the vertical line test, but it's not a linear function because it has this curved shape to it. The previous example in letter A was just that straight line, so that was a linear function. In letter C, it says match the equation y equals negative 2x squared to the correct graph. Well, easy way to do that is to simply type this in. Y equals negative 2x, and I click this button squared. It'll show me what that graph looks like. Because it's negative, now all of my x values are given that negative value to drop down in the left or right form, but the y value is going to be negative because it's multiplied by that negative overall. So the domain, again, the x values are all real numbers, left and right is all good. The range in this case is going to be y less than 0, so any negative number is going to be what turns out to be y in this case for this graph. To match that up, that looks like graph number 2 is our correct answer. In letters D and E, you can graph this equation and match the table with each of the graphs shown here. In letter D, it says y equals 1/3 x plus 1. Here's what you would do. Y equals 1/3 x plus 1. The x needs to be next to, that means it's being multiplied to show that rather than underneath. It's not a divisor. Here you have that positive slope again going from left to right. Looks like that's going to match with graph 2. If you've solved for one, you've solved for the other. You could obviously double check by typing in y equals 3x plus 1. And again, those correspond. So letter D is graph 2, letter E is graph 1. The other way to do that is obviously take your points and to check and see if those match. So you find where you have your zeros or find where there's positive values to see where those points match up, which I'm confident that you're able to do. In the last portion for letter F, it says identify the domain and range of the functions shown in each graph. Here we don't need to graph them with our graphing calculator. We just need to see where the x values go from left to right and where our y values go in that vertical sense. Here the domain is all the x values are greater than 0 because there's nothing that are in the negative portion. The range then is where all the y values are in terms of up and down. There aren't any y values that look like in this case are below what would be -1. So y is greater than -1. Here, letter G, your x values, if it's in this hyperbola fashion or in this curved fashion, the x values can be all the positive numbers and all of the negative numbers, so we call that all real numbers. Your y value has to be greater than 1 in this case because it's going up in this direction. There aren't any y values that are on this negative part of the graph itself. Okay, that should cover the practice problems that you're going to run into for today in terms of how to solve those with those examples. So watch the other instructional video and Mr. Shane's video to help you to solve those practice problems. God's blessings.